So once a researcher has identified their variables and constructed their hypothesis, they have a very good grasp as to what they want to learn. They still have a lot to decide, though, in designing the experiment itself and figuring out how we're going to collect the data to help us answer this hypothesis or test this hypothesis. And to do that, they have to make decisions about their design, their sampling, and what specific measurements they want to take. So, first question they have to answer is what type of design, experimental design, are they utilizing? Are they going to use a between subjects design or a within subjects design? So let me explain the differences between these two. First, by examining what a between subjects or between groups design might mean. And often again, when you read the literature and you look at the methods section, these types of statements are going to be made as to what type of design they utilized right there at the beginning of the methods section. So a between subjects design is probably best to understand if we go back to my example of we have a group of endurance athletes and we want to compare two different training programs with these endurance athletes to one another. So I want to compare a traditional training program and a novel one that I've created. And I want to see which one works better. In a between subjects design, the subjects are broken into two separate groups. So there are different subjects in each test group. So if I'm testing two different exercise programs, two different training programs for these individuals, if I have 30 subjects, I'd put 15 and have them do the traditional training program, and a different 15 have them do the new program that I've created. So in this example on this slide, what I have are 20 people. So I've put subjects 1 through 10 in one group and subjects 11 through 20 in another group. So in this design, it's called between subjects because I'm comparing between two different groups of people. In the case of a training study, that's typically what's used, right? It'd be hard to have people do both programs because we'd have to wait till the effects of one program wore off before we did the next program and so on. So it's easiest in this type of a training study to have different groups of people in each one, and that's what a between subjects group is. So each subject in your study is only exposed to one treatment condition. It reduces the chances of a learning effect, which I'll talk about here in a second, but it does mean you need more total subjects for the study because we need to have enough subjects, in each group to be able to make statistical conclusions. It's important also to make sure that you have similar subjects in each group so that if we see a change there, it's not because we put a bunch of different people in one group versus another. For example, if I had some people who had run before and some who hadn't, and I'm doing a study on the effects of a training program, and I put by chance, I happen to put all of the non-runners here in this group and all of the runners here, then what would happen is we probably would see a difference, not because of the treatment, but because I happen to have very different groups in each one. So in this design, what we see are two different groups of people placed in each category. They take a pretest, so maybe we measure 5K performance before we've done anything to them. We do the two treatments. This is the traditional program, this is the new program, and then we test them again. And we look at the post-tests. And we look at the change. So we look at how much they improved or didn't improve from the pretest to the post-test, and we compare the two groups. So if we see that this group has decreased their 5K time by 2 minutes, and this group has improved only by 1 minute, it makes us think that maybe our treatment had an effect. Okay, but that's a between subjects design. It's where each subject in the study only is under one of the treatment conditions. Let's take a look at a within subjects design. When it comes to a within subjects design or within groups design, what we see is a little bit different than a between subjects design. Sometimes this is called a repeated measures design because the measures are taken multiple times in the same subjects. In a within subjects design, each subject undergoes each treatment. So you could see how this might be difficult in a training study, but if we're looking at a very short-term, long-lived type of a treatment, such as foam rolling or something, then we can potentially use the same subject multiple times. So each subject undergoes each treatment in this type of design. We can see an example here where we have, again, 20 subjects. They would undergo a pre-test, then they would do treatment 1, and then they would be post-tested. So we'd be able to look at what their score was or performance was before the treatment, then do the treatment, then test again. And then maybe a day later, 2 days later, however long it takes for the effects maybe of treatment 1 to wear off, we have them come back and do the testing again, but under a different treatment condition. The positive of this design is that the changes due to the treatment are compared within the subject. So I can check and see how you respond to treatment 1 and then how you respond to treatment 2. In the between subjects design, what we had were different people in each category. So there is a chance that people themselves respond differently to the treatment. So because everybody isn't under all of the treatments, there's a chance that the differences we see are because the people are different or the people in each group are different. Versus in a within subjects design, we're comparing your results to your results, and therefore gives us some additional power, statistical power when making decisions. It allows us to utilize also fewer subjects, although the demands on those subjects are greater because they may have to test on multiple days. So again, a within subjects design is where we've taken this measure over and over. Now, I mentioned on the previous slide a advantage of a between subjects design is there's a limited chance of a learning effect. Here we can see the chance of a learning effect. If the test that we're using, the measure that we're doing, is something that a person can learn. For example, if this is a star excursion balance test, you get better at it after you do it a couple of times, and then your performance levels off. But there is a little bit of a learning effect, meaning as you do the test a couple times, you get a little better at it. So in a within subjects design, there's a greater chance of a learning effect affecting the performance on these measures. So for instance, if the measurement that we're doing in the pre-test and the post-test is a star excursion balance test, if this was the setup I'm using that's shown on this slide, they would take the star excursion balance test 1, 2, 3, 4 times. And since there's a learning effect, they would do better here than they would here. It has nothing to do with the treatment, but it's because they've gotten better at the test. So in the case of a star excursion balance test, what I'd want to do is give the person a couple practice attempts at it so that they've basically leveled off in their performance. So within a within subjects group design, we do have to be careful about the learning effect because some measures the person will learn and get better at. Some measures they don't, such as a 40-yard sprint, they don't necessarily get better at because, again, if they're an athlete and they're sprinting a lot, they don't improve much. But some agility tests and so on, they need a couple run-throughs to, again, kind of master it and learn how to perform it. So again, in this type of a design, it's somewhat stronger statistically, but often it's inconvenient or impossible to have the individuals perform under both treatments or multiple treatments, and therefore we have to rely on a between subjects design. You do see both within and between subjects designs very frequently in the literature within our field. Another important concept when it comes to designing and implementing a study is sampling. We talked about sampling pretty extensively in the qualitative portion of this course. Sampling is going to be important here, and I've kind of alluded to some of the reasons why. Ideally, if we're using a sample to describe a population, as we've mentioned before, ideally, if we know who the population is, you would randomly pick from that entire population for who your subjects would be. That would be random selection from the whole population, but that's really difficult. If you're looking at examining collegiate endurance runners, you don't have access to the runners all around the country. So typically in this example then, most often people sample utilizing what's called a sample of convenience. They randomly pick people from the people we have available to us. So maybe I work here in southwestern PA. I know some people at Slippery Rock and at IUP and at CalU that work with their cross-country teams. So I'm going to randomly choose subjects from those 3 collegiate teams. Now that's not as good as being able to pick from all of the teams, because maybe the coaches in southwestern PA all use a similar treatment or training technique, or because of the environment we train a little bit differently than other people, and so on. But again, often there's a sample of convenience that's going to be utilized, and that does bring some limitations to the study because it's not truly random selection from the entire population. A true experimental design uses completely random selection and random assignment to treatment groups. A quasi-experimental design, you'll see that term thrown in very frequently, means that they're assigned to groups non-randomly to ensure evenness. And quasi-experimental means that it's not truly a random set from the population. It may be a sample of convenience. And then obviously that sample is then going to be either utilized. The people that you pick for your study are going to be either utilized in a between subjects design or within subjects design. And typically we will randomly assign the people to the treatment groups. Sometimes we'll use non-random assignment, which we'll talk on a future slide. But again, the random assignment to the treatment groups is going to be very important in a between subjects design. In within subjects design, we don't randomly assign them to the treatment group because they undergo all of the treatments. However, we usually randomize the treatment order so that they don't do treatment 1 first always. We sometimes do treatment 1 first for some of the subjects, others they do treatment 2 first, and that helps to minimize the chances, again, of a learning effect affecting our outcomes. The timing of the measurement also is going to be important. We want to have an idea of when we're going to take measurements, how often we're going to take measurements, and so on. Typically, in most studies, we do some type of a pretest to see where they are on the dependent variable before we do anything to the subjects. Sometimes we'll use the results of a pretest to even assign people to treatment groups. So again, if I'm looking at something related to speed, I may want to put some fast and slow people in each of the treatment groups and not run the risk of having all the fast people in one group where it's much harder to potentially have speed gains and so on. So often we'll do a pretest before the independent variable or the treatment is applied. And then obviously we'll have a post-test afterwards to see if there was any change in the measure as a result of our treatment. Sometimes we need to do additional measures. Sometimes we want to look at the how long an effect persists. So again, if I wanted to look at my training program and how well it enhanced performance after a 6-week training program, I may measure people at the end of 6 weeks. I may then allow them to do no training for several weeks or several days and retest them to look at how quickly detraining occurs. Or if I'm looking at potentially foam rolling and I want to see, again, does it increase range of motion right after treatment, I also want to see maybe how long that treatment effect exists. Does it exist for 5 minutes, 10 minutes, an hour, a day later? Are those gains kept over several days, or do they quickly go away? So we may look at various different timing ideas related to the measure that we take. So one common design we see is a pre- and post-test design. That's very common in the literature, very common in our field. And that's, again, where we do a pre-test before we do something to the subjects, we do a treatment, and then we do a post-test. That helps measure the change and account for differences in group assignments. So again, if I do happen to have people that are fast in one group and slow in the other, and then I measure them after a treatment, what I'm looking at then by doing a pretest and a post-test, I'm looking at the difference in their measures from before and after, as opposed to just the difference. A post-test only design only measures performance at the end or after the treatment. It does eliminate the chances of learning effect because they're only being tested once, but it doesn't account for pre-existing differences that could have existed in the groups. Carrying out the experiment involves a number of steps. The researchers will find subjects. They will assign the subjects to groups, as we've said. They'll develop their hypotheses and so on. And then we manipulate the independent variable, the treatment, with the subjects. So again, if I go back to my experiment where I have two different training techniques for these athletes. So I'm using a between subjects design. I have two groups of endurance athletes, one that are doing a kind of a traditional training program, one they're doing a HIIT-based training program. It's important for me when I assign my subjects to the groups to try to have an equal number of men and women in each group, equal number of novice and experienced runners in each treatment group, and so on. I also want to control as many factors as possible. So if I'm doing a 6-week training program, the researcher really needs to try to control as many things as possible. That may include, again, if I'm comparing these two training programs, making sure they aren't doing any additional training on the side, making sure they're not doing some other activity that's actually going to bring about some changes in their performance as well. I also want to try to limit things like maybe food intake. Tell them, make sure you keep eating the same thing you normally eat. Prescribe a specific diet, and so on. I may be concerned about medications. I might want them to not engage in other sporting activities, and so on. The researcher typically attempts to control as many factors as possible. And this is really difficult, especially in the case of like a training study where we need for 6 weeks them to, again, limit some activity or limit themselves to only the activity we prescribe. So again, we need to control as many factors as possible. We have to think about the timing between treatment sessions, testing sessions, and so on. And then we also have to pay attention very carefully to even things such as the type of instruction that we give a person. If I have them doing a test of some type and I don't give the person, each subject, the same instructions, they may perform differently because I didn't give them as good instructions, or I didn't give subject 1 as good instructions as subject 2. Another example that is seen in the literature is the effect of encouragement. If one person's doing a test and I'm encouraging them, I'm yelling them to go faster, push harder, whatever it may be, and another one I just let them do it on their own, the effect of my encouragement can be significant. So we have to make sure we treat each subject the same in how they're tested, how the treatments are conducted, and so on. So again, that's really difficult for the researcher, and they will typically detail the efforts they've made in this area in the studies that we read. They also have to collect the data using the appropriate and the best tools. We talked about validity and reliability a few presentations ago, so keep that in mind. If they are testing the people on the 40-yard dash, we want them using a laser timing system because that's the best way to do it. We don't want them to use a stopwatch because we see there's some reliability and validity issues with the stopwatch when compared to other testing techniques. So again, we want to look at they're using the appropriate tools whenever possible. So I want to look at a quick example of a study and have you think about these things. So I'm going to ask you to pause the presentation. And I've supplied you all with the link to, as well as the PDF of this article. This is an article that I've mentioned numerous times in other presentations in this class. It gives us a real good example of an experimental study and allows us to identify a lot of different things. So I'd like to give you a quick thought experiment where you read this article, okay, pay attention to the different things, and then answer these questions. We'll then come back and we'll answer them here. But I want you to think about what is the independent variable or variables in this study by Romero Moraleda. And I want you to again, identify the dependent variables. So what were the independent variables? What were the dependent variables? Did they use a between subjects or within subjects design? And then how often were the measurements taken? So take a look at that article that examines the effects of vibration and non-vibrating foam rollers on recovery. and answer those 4 questions. You can just write those 4 questions down and their answers on a sheet of paper. You'll need your answers at the start of the next presentation.